start recording. Hello guys, today we're gonna learn about ETABS 2016. ETABS is just simple to use. First, you make your structural model, then you define the important factors such as the seismic factors and the other load factors. And then you assign the loads to your structural model. And then you rerun the analysis, then we proceed to design the rebars if needed. Let's go back to ETABS. First, in making your model, choose your preferred units. I'm using metric SI units. Now for design, I have 10 number grids, 5 in Y, 4.5, 4, 6 stories, and 4 top to bottom story height. And let's just use grid only this time. After making a model, first you define the section properties. First, the frame sections. You need to add your beams, columns, and slabs. So let's start with beams. Just create a new property, beams, name it after the depth. Then modify the rebars and set it to beams. Then hit OK. Then add a new property for the columns. Name it after the depth again, which is 900 mm. Then set your preferred width and modify and set your longitudinal bars and confinement bars. Make sure that your reinforcement configuration is rectangular and the confinement bars are ties. Then hit OK. Then define again the slab sections. We need to add two new slab sections for the flooring and the stairs. So let's first make the stairs. I name it slab stairs and change the thickness into 120 mm. And then you add the new slabs for the flooring. You can name it slab flooring or simply slab 200 to indicate its thickness, that is 200 mm. Hit OK. And then proceed to making your model. Set the columns. Click the all stories. Now the columns have been placed. You can now proceed to place our beams. You just click the beams in the desired place you want and remember to click the all stories. Now after we add the desired beams and columns, let's proceed to a more complex step like adding a shear wall. A shear wall will provide us this elevator shaft for our 6-story building. Adjust the dimensions of your shear wall to fit the dimensions of your structure. You can always change the thickness if you want, but in this case I won't. Then I'll just snap it in the middle there. Simply click and delete the joints by pressing the delete key on your keyboard to make an open shear wall for your elevator shaft. There. Now, our building is gonna need some stairs, so we're gonna make some stairs. Use draw, then click, and then offset. This is just a tip. You can do it however you like. Then draw the slab using the property of the slab of the stairs. Now we need to offset the slabs that we just made in order to place them in the middle of the story of the building. So we just cut them and then place it back again, but this time we offset its elevation by -2, 2 meters to make it in the middle of our stories. Then next we divide the shells, then divide the beams. Just hit edit and find the particular editing frames for the beams and shells for the slabs. Then divide the frames into two. Now simply draw a slabs using your stair slabs and start from the bottom to the upper part because it will glitch otherwise. Then again to the other side, just complete the parallelogram. There you go, you have a stairs. Now you can go back to 2D wireframe and we can show all objects. Let's proceed to adding the floor slabs. Then use the slab 200 for the flooring. Just click slabs wherever you want. Now, since the base of the building won't need reinforced concrete slabs, we will need to delete the excess concrete slabs that's in the base of the building. So simply select the plane and select base, then OK. Then change the mode from all stories to one story only and proceed to click and delete all the excess slabs. Now, after successfully removing the excess slabs, this would be the result. If we hover and then our 3D, we can see at the base that there are no more excess slabs. Oh, there's another excess slab. You just click and delete. Next, we need to assign the joints and the restraint of the joints. So just highlight the joints, then proceed from one story to all story. Change the mode and then proceed to assign. Assign joint, restraints, and choose the figure or click everything in the checkbox to make the restraint for fixed. Then hit apply and OK. Now, right fun. We have done making our basic structure. It is now time to define the important factors. First, we assign. Gago, ipakatawa mo ko niyo. First factor to define is the load patterns. In the load patterns, it is it is described in the NECP that we must have at least 4 for less than 10-story building. So we have already have dead load and live load. We need the remaining two, which is the superimposed. Let's call it superimp, and set the type to super dead. Then click add. Then the other, let's call it as seismic load, and set the type as seismic, and change the lateral load to the UBC97. Click add, and let's further on modify the lateral load for seismic load. Now we can see here the first in the direction and the eccentricity. For simplicities, we just need the x direction and the positive eccentricity, and the y direction and the positive eccentricity. Uncheck the others. Make sure that the eccentricity ratio or the diaphragm is 5% or 0.5. In the time period, you can use either of the three: the method A, program calculation, or user defined. Let's just use the method A, which is given in the NCP standards. If it's in feet, it's 0.03. Now, change the soil profile type depending on where the location might of your structure. Now here in Kabakan, if you can research it, it would be SD type. And the seismic zone factor, which is also searchable on the web, is 0.4. And the overstrength factor, remember, 8.5 for all concrete structures. And then the seismic source type. It will also depend on the location of your structure. Here in Kabakan, it will the seismic source type is type B. And the distance to the source, the nearest source would be, if you find it on the web or you have a locator app, it would be 42 kilometers. And the importance factor, let's just leave it to 1. Then hit OK. Then hit OK again. Next, we define the functions. The next is the response spectrum. The response spectrum, change to UBC97, then hit add new function. Name your function as the RSA or response spectrum of whatever area you have. Then, if we can remember earlier, when we defined the load patterns for the seismic load, we have a user defined values of CA and CV, which is 0.44 and 0.64. Let's apply it to our RSA. Okay. Back to the RSA. Oh, shoot. Change it again. Hit add. Then, the coefficients, plug it there. Change and RSA. Then hit OK. Then, next, we go down and define the mass source. The mass source should be elements, self mass, and some additional mass. This is perfectly fine. Do not change and hit OK. Then, as we go down, model cases. Let's add a new case. Set it to model 2, change it to 15, then hit OK. The model number is just assumed. You can change it wherever you find something more accurate. Then, the next in defining, we go to the phi delta. The phi delta, in phi delta, it is, uh, the phi delta is important because it is stated in the NSCP 2015 under the section of 208.6.3 that resulting member forces and moments and the story drifts induced by P delta effects shall be always considered. So therefore, by using the basic formula that 1.2 dead load plus live load or 1.2 dead load plus 0.5 load, we can use these values to plug in our ETABS. So the dead load, which is 1.2, and the live load, I forgot to set the dead load to 1.2, then click add, then set the live load to 0.5, click add, and the superimposed as same as the dead load, which is 1.2, then hit add. These three only, then hit OK. Next, we define our load cases. Now in our load cases, it is already defined. The dead, the live, the superimposed, the seismic, but we need to add the new case, which is the RS load. The RS load or the spectrum. Then add two direction for X and Y, U1 for X and U2 for the other. And then to properly identify the scale factor, let's just use a calculator and calculate the scale factor. Simply just divide 1 by the overgrowth strength. So therefore 1 divided by 8.5, then multiply it to the given scale factor, which is 9806.65. Take the answer and round it to the nearest whole number. Let's just say 1154. 1154. Then hit OK. Hit OK. Now that we are done defining the important factors and loads, we can now assign superimpose loads or whatever loads we can do. The loads on the beams and the loads on the slabs. Let's start by showing all objects. Oh, here. Look, bug. Oh no. Pause for bug. Next, we apply the loads. We apply the loads on the external walls. So we highlight the external walls. Now the selection is complete. In selecting the outer walls, make sure that the all stories mode is on. Then hit the assign button and assign frame loads, the distributed, and hit the superimpose loads. And assign the load, which is, for my case, it's 9 kilonewton per meter. Then hit apply, then OK. As you can see, there are numbers 9 shown in the figure. We make it a 3D. You can see the loads that are superimposed. If it's just an eyesore, you can make it go away. Just simply clear display of assigns. Then let's go back to top view. Now for the loads of the slabs. Make sure again that all storage mode is on. Then proceed to highlight all the slabs. Then hit assign again. This time we assign the shell loads. Hit the uniform and change the load pattern name to live and change the load to 4 kilonewton per meter square. Then hit apply and OK. We should see numbers 4 in the middle of the slabs right now. To clear that, just simply clear display of the assigns. Now, all that's left is, now we're done at assigning loads. Now let's just run the analysis, then proceed to reverse. First, we lock the model, then by clicking this lock icon and then hit the run analysis or F5 at the side of it. Hit run and then save your file. Then wait for it, wait for it. Hello? May loading bar, may analyzing. To you. No. Ni. As you can see, the animation is complete. Let's start the animation. Now you can clearly see how your structure deforms when stressed to loads and earthquake. Next, say next. After running the analysis, now we are the part that we can decide if we're gonna go to rebars. Now, if you, if you look to display shell stresses and forces, we can now display the effects of the loads and the assigned factors to our structure. Let's hit show contour options and hit apply and OK. See, you can see the stresses color coded on our slabs. Let's clear that and try checking the member force diagrams. Hit the shear, apply. Okay. Here, if you right click, you can directly, you will know the the diagrams, the moments per member that you right click. See, it's in the component V2 and M3. You can easily locate it there. Show multiplication. You can see the length, absolute, relative to story. Yeah. Let's clear this. And you use the icon here. You can see the results. And now, at the 3D view, we can now verify if all members have passed. Now, all members of the concrete have passed the design check. Even if all the members have passed, we can still do some rebars, revising rebars for columns and beams. You can always hit and change the values here for your satisfaction. Then after changing the values, let's try changing the values now. Let's try to design it to fail. Let's set the bar to the smallest possible. Let's see if it would fail. Hit OK. Then verify again if all members will pass. Now, you see, it, it has verified that 167 concrete frames have not yet been checked. You want to select them? Click yes. Just wait for the checking to be done, and let's see the effect of the values that we have changed. Forward. Now, if you verify it again, clearly, all the concrete frames still finds the design check. Wow. Just if you right click here, you will see all the information that you need. If you want to reverse again to do checking and hit summary, this now, you can print it, you can present it to your clients, and all is done. Thank you.